Good morning, friends. Let's solve past paper questions from dimensional analysis. NEET past paper questions. Before diving into the past paper questions, let's ask simple questions. What is a dimension? What is dimensional analysis? Is there any trick and tricks to solve these questions? What we can expect? What type of questions we can expect in the question paper? So these things. First, the very fundamental question: what is a dimension and what is dimensional analysis? So dimension, people think that dimensions are just unit. No, they are not. They are more fundamental than unit. So dimension is a parameter. Okay, you're talking about the parameter, not about the amount of parameter. For example, let's say I want to measure some distance. Okay, what you're measuring is length. Okay, now this is a dimension. So whenever you name something some dimension, then you ought to draw the square bracket. Okay, this means that you're talking about the dimension. For example, symbol for length is L. Okay, the units on the other hand, they can have various values depend on what you are measuring. For example, you can measure the unit in meter, centimeter, kilometer. Obviously, they are not same. Okay, they are tens of orders of difference, and dimension is the same. Okay, so these are the unit. These can be different, but the dimension is same. So we have 7 basic dimensions. Only 7 basic fundamental dimensions. We do not have more than 7 dimensions. Okay, so the namely length, mass, time. Okay, you can denote this by L, M, T. So these 3 very fundamental. And then we have temperature. Okay, so this we can denote this as K or theta. Any letter you can use. And then luminous intensity. Okay, so this you can use CD. And current, this you can use I or A, ampere. Okay, so apart from this, we have one more dimension, that is amount of substance. Okay, so this you can use J, sorry, not J, mole. Okay, let's take it as of now, mole. Oh, sorry, I wrote these things here. I can take a look here. Okay, so we have length, mass, time, temperature, luminous intensity, current, and amount of substance. In this, as of now, grade 11 and 12 CBSE book, physics book, NCERT book does not deal with the luminous intensity and amount of substance in dimensional analysis. But you can expect in the questions, but so far there are not so many questions been asked in the past papers using this luminous intensity and amount of substance. But others have been. Okay, so you just it will be okay to get to know them, the luminous intensity and amount of substance diamonds, but you have to concentrate more on the others. Yes. Okay, so that's dimensions. Now, what is a dimensional analysis? In general, dimensional analysis means that you are analyzing the dimensions in a physical equation. Okay, so two way it can go. One, for example, you are going and asking something, how far it is this place from here. Okay, so what you're asking is a question that's answerable in length. For example, how much is New York from LA? You can ask. Okay, what you're asking is distance. The person who's answering have to answer only in distance, right? What if he says 5 kilogram? So that's not just wrong, but completely irrelevant. In a nutshell, that's dimensional analysis. What's been asked should be given. That's a dimensional analysis. So what are the dimensions in the left hand side? That should be the dimensions of the right hand side. And this is the very fundamental thing that based on this, more and more questions will be asked. Okay, in the dimensional analysis sessions in NEET and JEE both in general physics. Yes. Now, okay, how What's it? For example, you are asking length, okay, this side. Let's say that that person says it's just how much? Approximately 4,000 kilometer. Okay. So this side length been asked and this side length been given. Okay. And you should note that it doesn't matter in what unit he gives answer. He can give it in centimeter, he can give it in meter, he can give it in light year. It doesn't matter. As long as he's giving in some form of meter, the length, okay, or foot, whatever it is, foot, some form of the length, it's fine. Let's say that if you draw, if you drive 1,000 km/h, you can reach it in 4 hours. Okay, let's say that he gives 4 hours. Okay, provided that if you drive 1,000 km/h. So this also a right answer. Is it dimensionally correct? Let's check. So 4 hour is a dimension of length. Okay, sorry, dimension of time, and 1,000 km/h. Okay, so this is 1,000 km, which is dimension of distance, divided by hour, that is dimension of length. So this can cancel out. Finally, what you are getting is 4 into 1,000, which is 4,000 km. So dimensionally right. Yeah. So this is how it works. What's been in the left hand side should dimensionally equal to what's been in the right hand side. So this side you can get answers in centimeter, that side you can get answers in light year, but as long as both side is distance, you are right, dimensionally right. That's one advantage. Also one disadvantage of dimensional analysis. Okay, before going into disadvantages of dimensional analysis, there is some concept called homogeneity of physical equations. What it says is only same parameters can be added. For example, you can add only length with length. Again, you can add kilometer to centimeter, centimeter to kilometer, doesn't matter. But you can add only length to length. You cannot add length to mass. Okay, 5 kilometer plus 2 kilogram you cannot add. But 5 kilometer plus 0.002 centimeter that you can add. Yeah, that's the thing that you have to remember. So if you're adding something, meaning that they are same dimension. Let's say that I'm adding A and B, which gives me C. It tells me that A and B are dimensionally same. Eventually, C is also same dimension. This concept also we are going to use to solve a lot of questions. Okay, so this is called principle of homogeneity of dimensions, that you can add only the same dimension, okay, in the equations. But you can multiply with anything. Okay, for example, we know that speed is distance by time. If you want to work out what is distance, then that is speed into time. Okay, so they are different. Speed has different dimensions and time has different dimension. That we can multiply any different dimension, but you can add only the same dimension. This you have to remember. You can add only same dimensions if two quantities, or if two part of the equations been added, their dimensions are same. This you have to remember. This will help to solve many questions. Yeah, okay. So we have looked through what are the fundamental dimensions, and then we just see what is homogeneity of dimension, and there are some limitations to this dimensional analysis. Okay, so what are the limitations? One, so as we discussed earlier, so dimensional analysis is not precise. So what do you mean by precise? It can give you an answer that you will get the answer of length. You will get the answer in length, but it will not give you what's the quantity. Okay, how much length you will get answer. It will not. Okay, so no unit. Second, so this is a new concept. So remember before 7 we discussed there are 7 fundamental quantities, right? There is one more type of dimension which is called dimensionless. Um, Okay, dimensionless. No, I don't have small eraser. Yes. Okay, so dimensionless quantities or parameters. So there are some quantities that they do not have dimension. For example, ratio of any same quantity. For example, ratio of length to length. Then in numerator also you will have length. Denominator also you will have length. So the overall dimensions you get a dimensionless quantity. Okay. What else we can think of? Ratio of intensity 1 of medium to intensity 2 of medium. That also. Relative intensity is a dimensionless quantity. Refractive index is a dimensionless quantity. Apart from this, why refractive index is a dimensional quantity? You can give refractive index in two things, okay? 1 by sine C or sine I by sine R, okay? So if you look, the sine I and sine R, we'll talk about cosines and sines in a minute, but they ought to be have same dimension, right? So they cancel out each other. So it's a dimensionless quantity. How about this 1 by sine C? Any sine function, any trigonometrical function in general, okay? Any logarithmic function, any exponential function are dimensionless. So if they are in part of your equation, you cannot be precise what is the dimension that inside. For example, I can say sine some x, okay? So this is dimensionless. How do you denote dimensionless? Mass power 0, length power 0, and d power 0. If you write like this, in general, any dimension power 0 is any dimension power is 0. Okay, sine x is 0. But this x dimension should be 0. Okay, so x can have different values. For example, inside it can have omega t or 2 pi as a pure number, anything. So that's dimension should be 0. This you have to remember. Same goes for e power something. For example, you know this famous equation, okay? N equal to n naught e power minus lambda t. Let's say. So now anything e power is 0. So e power minus lambda t. So this is a dimensionless quantity. As you can see that you're dividing the same number by, same quantity by same quantity. So you will end up in dimensional analysis 0. So e power minus lambda t should be 0. So what the lambda should have the inverse of t. Then only you can have minus lambda t, this dimension as 0. You have to remember something's dimension is 0 doesn't mean that the quantity is 0. Okay, they can be pure number, ratio of some same numbers, some trigonometrical function. They are not 0 in value. They are just 0 in the dimensions. This you have to remember. Okay, so this is one limitation. And third, and this is very important. If you found out the equation that is dimensionally wrong, meaning that the equation is wrong. Okay, if you find some equations, you're okay working out the dimensional analysis and you found out that its dimensions are wrong, then it's wrong. But if the equation is dimensionally right, it doesn't mean that the equation is right. Okay, you can tell 100% wrong equation by dimensional analysis, but you cannot tell 100% right using dimensional analysis because of these limitations. Yeah. So if it is involving some dimensionless quantities, you cannot bring down the actual value. Okay, actual parameter what you're looking for in the dimensional analysis. If dimensional analysis right doesn't mean it's 100% guarantee that the equation is right. Okay, and they do not give you units. They just give you the answers in arbitrary form. Okay, you will get length, you will get mass, you will get time, or you will get multiplication of mass and length, mass and time. Okay, so these 3 points are very important. And then with one example, just one example, um, The application of dimensional analysis. Okay, I think that example is included in the past paper, so you do not need to see it precisely. So we will look at, we will solve questions, NEET past paper questions from the dimensional analysis to have more understanding. As we solve, we will learn a little more. And yeah, okay. So we'll move to next question. Okay, the first question. The dimensions of stress are. You know what is stress? Okay. So stress is pressure. So which is nothing but force by area. You know what is a force also? And here is how you can get dimension of any physical quantity. Okay. So if you want the dimension of a stress, you just have to work. You can take any formula that stress involves and keep the stress in the other side. Move all the units to the other side. By homogeneity, they both have to be same. Okay. So what is a force? We know that force is mass into acceleration. You can take forces mass into acceleration, or from energy you can take force, anything. Okay. So I know that mass has dimension of just mass. Acceleration is distance divided by time square. Yeah. So it's L divided by time square, which is t power minus 2. Okay. So, so it's time square. So if I move this up, you will get t power minus 2. So that's dimension of force, mass into acceleration. And I know that area is some length into length. It can be length into breadth or length into length, whatever it is. Okay. In the case of circle, it's length square, just radius square. Okay. So some form of length into length or length square. So you will get the dimension L square. Okay. So what do we want? Dimension of pressure or stress. So dimension of stress is force divided by area, meaning the dimension of force divided by dimension of area. So the dimension of force is mlt power minus 2 divided by dimension of length, sorry, area is length square. And this is very important point. You can cancel only the same dimension. You can multiply, divide, add, subtract, do everything, but only with the same kind of dimension. For example, only mass can be added to mass. Only mass can be divided by mass. Only mass can be multiplied by my mass. You cannot take the length power and do it to the mass. Okay, this you have to remember. So L square, we have L, so we will have L power minus 1. So in general, the dimension of pressure will be m L power minus 1 T power minus 2. Okay. So that's the dimension of stress or dimension of pressure. Do we have that in option? M L power minus 1 T power minus 2. Yes. I think C is the right answer. Yep. Okay. So what do we learn from this? Dimensional analysis you can perform by taking units or formulas. Okay. Just omitting the pure numbers, taking what's the parameter and then do it. Okay. So let's solve more and more questions so we can find. Okay, let's move to next question. If force, velocity, and time are taken as fundamental units, then the dimensions of mass are. What they're asking is you have to find the dimension of mass using force, velocity, and time. So this can be done two ways. One mathematically, other one qualitatively. Okay. Yeah, qualitative. So first let's do qualitative. Do I know any formula that involves force, velocity, and time that involves mass? Yes, I know. For example, force is mass times acceleration, and acceleration is velocity by time, that I know. So force is mass into velocity by time. What do I need? Only mass this side. So I have to keep the mass this side, move everything else. So mass is force into time divided by velocity. So what do we have here? force power 1, velocity power minus 1, t power 1. Okay, so that's our answer, final answer. So the dimensions of, so if you take these quantities and multiply, you will get your answers only in mass. That's what this equation means. Do we have that in option? Option 4 is yeah. So force, velocity power minus 1 and time. Now, okay, let's do the mathematical way for the some other big questions. So it is very easy to understand rather than confusing in this question. Yes, let's move to next question. This question. The dimension of universal gravitation constant. So we know that gravitational constant is capital G, and this super important and very much worth remembering the dimensions of gravitational constant. If you remember, you can directly answer. If you do not remember, you have to find a way to find or deduce the dimension of this gravitational constant. Which equation we know that involves gravitational constant? Yes, Newton's gravitation. Okay, so force is gravitation, m1 m2 divided by r square. Now we want only the gravitation. Okay, so gravitation is force into r square divided by m1 m2. Both are mass, so you will get mass square. So you get force dimension multiplied by r square, which is length square, divided by mass square. We know that the force dimension earlier from, you can remember, force is mass time acceleration. So mass m, acceleration is L t power minus 2, m L t power minus 2. That's force that you have to remember. M L t power minus 2. This is force into r square is distance square, which is L square, divided by mass square. Okay. So now all I just have to do is this little algebra numbers, not even algebra, numerical. Yes. So m square, I'll go m inverse L cube t power minus 2. So that's my gravitational constant dimension. You have to remember, you will remember. Even if you cannot remember, you just learn how to do this from the formula. This will help you in great deal, and more, all the complicated, not all, most of the complicated questions in dimensional analysis will involve somehow this format, either this Coulomb formula or this gravitational constant. Okay, so we'll see in the following questions. Yeah, gravitational constant. And one more application of the dimensional analysis is, maybe we can go back to that slide, conversion of units. Okay, so we can look at the first or second example in the dimensional analysis session in NCERT book that you require to convert from CGS to standard system international unit. Okay, that also in one of application of dimensional analysis, one of the application. Yes, it's very easy. What's the answer? M inverse L cube t power minus 2. Yes, so option. The dimensional formula of torque is, okay, so the symbol for torque, this is called tau. Now, either state board or NCERT book, end of the volume 2, I guess, that you have a list of dimensions, the list of quantities and dimensions. Like, I think around 100 quantities are there. If you want, if you don't want to have any problem with the dimensional analysis, I suggest you go through all the list. Okay, if you go through all the list, you can answer this question in single line. But that's a difficult one to memorize all the quantities and their dimensions. But the easy one is to remember the quantity as its formula or as its definition. Then you can answer any question. For example, torque, we know that in general, what is torque? Force into distance, perpendicular force. Okay, and the distance from the pivot. So force into distance. So this is the torque's formula. What's the force dimension? Mass into acceleration, ml t power minus 2 into distance is L. So you will get m L square t power minus 2. L into L is L square. So that's your torque. And we have, yes. So what's it? One more, yeah, we'll learn more and more as we solve more and more. One more thing in the dimensional analysis is, let's work out for energy. We know that energy, what is energy? Also force into distance. So you will end up the same dimensional formula for the energy. Okay. Same for work done. And what's more interesting is once you find the dimension of energy, okay, see, we just find the dimension of energy, force into distance. We didn't specify whether it's kinetic energy, is potential energy, or elastic energy stored in a spring. Doesn't matter. They will all have the same dimension. Okay. Can we just try only one? One. Okay. For example, I want to work it out potential energy, which is mass into gravity, acceleration due to gravity into h. I know that mass is m, gravity is acceleration, which is distance by time square. Okay, into h is just m. So I'll get m l square t power minus 2. See, same. Let's work out half mv square kinetic energy. Numbers does not have dimension. So when you are dealing with dimension, you will not take numbers, e value, pi value, r value, any constant value you will not get. Okay, but there are something called dimensional constants that we will see in future question. For example, gravitational constant is a dimensional constant. It has a numerical value, also it has a unit. Okay, dimensional constant. So those are called dimensional constant, but in general, not numbers will not have any dimension. Okay, dimensional constant different from constant numbers. So mv square, m is mass. We know that velocity is distance by time, so L t power minus 1, but this is velocity square. So m, if you square this, L square t power minus 2, 7. Okay. So it doesn't matter molecular energy, bond energy, any energy if you take, you will get the same dimension. It's the beauty of dimensional analysis. Once you dictate what is energy, then it goes for all energy. Yes. So dimensional formula for torque is ml square t power minus 2. Okay, let's move to next question. The dimensional formula for angular momentum is, again, if you remember from the textbook, it's you can directly answer. But if you don't remember, you have to remember the formula. Let's denote the letter L, angular momentum. Okay, angular momentum is moment of inertia multiplied by angular velocity. Okay, so moment of inertia is mass into distance square. So that's m L square multiplied by angular velocity is not L by t inverse. Okay, the velocity is velocity is distance by time. Angular velocity is just divided by time. So it's frequency. Angular velocity simply denotes frequency 1 by time. Okay, so now the angular momentum will be m L square t power minus 1. That's your dimension. Angular momentum. Yeah. Where do we have? I think 2 is, yes, 2 is the right answer. Dimensional formula for self-inductances. Self-inductance. So we have the formula for self-inductance. So summation, which is EMF, is minus L di by dt. I think this is the formula. Yes. Okay. Like how you ignore the numbers, also you will ignore the sign, positive or negative. You don't care in dimensional analysis. Within the equations, also you don't care because you can only add and subtract same quantities, right? So it doesn't matter whether you add or subtract. So this has dimension of voltage. This dimension we have to find. This has dimension of current. We'll just write it I or ampere A. This has dimension of T. Okay. So how do you find the dimension of voltage? Okay. So using Actually, voltage, you can define this as energy by charge. Okay. Again, charge doesn't have dimension. Charge, you have to use current is charge by time. Okay. So charge is current into time. So this is how you have to find the voltage. So again, you have to replace this energy by current into time. This is how you get for voltage. We know that energy is ml square t power minus 2. Current is I, so ampere power minus 1. Time is t, so t power minus 1. So we'll get t power minus ampere minus 1, t power minus 1. And you will get ml square t power minus 3 ampere power minus 1. So this is the voltage. Okay, am I right? Yes. So voltage, so I just rewrite this equation for L. L is EMF dt divided by di. Okay, so this is just dimension of voltage, and this is the dimension of current, sorry, time, and this is dimension of current. So we'll get ml square t power minus 3 ampere inverse into dt is just time divided by current is just ampere. So this doesn't cancel out because it's ampere and ampere inverse. So it will add it to the numerator. So ml square ampere power minus 2 t power minus 2. Okay, that's my self-inductance. ml square a power minus 2 t power minus 2. Do we have something like that? I think option 3 is the right answer. Yes, now you have idea how to find dimensional for any quantity that involved in a formula. By the way, all the questions are past paper questions, either NEET or AAPMT, whatever the question. Okay, and I refer Arihant physics book to get these questions. Yes. Okay. So dimensional formula for inductance, self inductance is ml square a power minus 2 t power minus 2. Yes. So this is one model of questions that can be asked in dimensional analysis. They give you different quantities and they will ask you which two have same dimension. So what we have to do, we have to work it out all the dimensions. Okay, which two of the following 5 physical parameters have the same dimensions? Okay, remember you have to know all the formulas or their dimensions, then only you can answer this question. So what's energy density? Energy density is, okay, energy density is energy by volume. So we know that the energy dimension is ml square t power minus 2 by volume is L cube. So you will have ml inverse t power minus 2 cube downsides, L square in the top side. So we will have L inverse. Okay. So refractive index is a dimensionless quantity, doesn't have a dimension or 0. Dielectric constant also dimensionless quantity, so it's 0. Young's modulus. Okay, Young's modulus is stress by strain. Strain is a dimensionless quantity. Okay, how? Because stress is force by area, we know. Strain is extension by original length. Both have same dimension, so it's a dimensionless quantity. So you will end up Young's dimensional is same as pressure dimension or stress dimension, force by area. So L inverse t power minus 2. Okay, so Young's modulus. And magnetic field. Magnetic field, you can get the dimension from any one of the equation. For example, force is BIL sine theta. Okay, we leave the sine theta because it doesn't have dimension. No problem. So we need B, which is force by current into length. We know that the force is m L power t power minus 2 divided by current is A, length is L again. So L cancel. So what you will get is m t power minus 2 a power minus 1. So that's dimension of magnetic field, you can remember. Sorry. So which two have same? Energy density and Young's modulus have the same dimension. Okay, you can think 2 and 3 have same dimension because both are dimensionless quantities, but it was not in the option 2 and 3. Even it was there, they're asking which has same dimension. They zero refrigerator and zero television cannot be equal. 0 and 0 equal, so refrigerator cannot be equal to television. Yes. Okay, now we remember we learn about magnetic field, energy density, and Young's modulus. Nice. So 1 and 4 have same dimension. Okay. So if force, acceleration, and the time are chosen as the fundamental physical quantities, find the dimension of energy. So we already discussed this type of questions, like how you can find using the formula. So there is one more method that you can use. That's mathematical way of answering this question. Okay. So what we have to do, find the dimension of energy. Okay. So the left side you should have the dimension of energy. In the right side, some combination of these quantities: force, acceleration, and time. If you can find any formula that involves all this quantity, it's very fun. You can directly do it. This case also, I'm sure that we can find if you think for first like more than few minutes, but in few minutes. But it is not probable, not very easy to do for all the quantities. Okay, so you have to do the mathematical approach. In mathematical approach also, you can do two types. Okay, the first is pure mathematics. You do not need to think anything, you just have to work out the mathematics. For example, in this case, some power of x, some power of okay, some power of acceleration and some power of time has to have the dimension of energy. Okay, we know that energy is L square t power minus 2. Okay, force is ml t power minus 2 x L t power minus 2. Acceleration is yes pi, and time is just set. So what you have to do, you have to equate all the m power this side, all the L power this side, all the t power this side. If you have all the ampere, candela, whatever it is, to that side. For example, let's calculate what are the all the m power here. So here I have m power 1. This would equal to, so m power x plus I don't have y, also I don't have z. Okay, so law of integers, base are same, the powers are same. So x equal to 1. That is easy. Okay, let's calculate the L powers. Okay, so I have 2 here. This side I have 1x. So x plus 1y. I don't have a set. So x plus y is 2. I know that x is 1. So 1 plus y is 2. Y is 1. 2 minus 1. So y equal to 1. So x equal to 1 I found. Y equal to 1 I found. Let's equate the z powers, t power. Okay. So this side I have t power minus 2. This side I have t power minus 2x. Okay, I have, and minus 2y I have, plus z. Okay. So I just have to equate this and this. Minus 2 equal to minus 2x minus 2y plus z. We can switch the minus sign both sides. So 2 equal to 2x plus 2y minus z. I know that x and y values are 1. So z, I'm just rewriting this equation. Z equal to, yeah, actually I do not need to go to this step. Yes, I'm just rewriting this equation. Z equal to 2x plus 2y minus 2. Okay, I know x is 1, y is 1. So 2 plus 2 minus 2. So z is 2. So e power, sorry, e is force power x, x value is 1, so force power 1, a power y, y value is 1, a power 1, and t power z, z value is 2. So f power 1, a power 1, t power 2. So what we have done here is we took the dimension of energy this side. We want to equate that with some combination of force, acceleration, and time from this side. So mathematically, we equate the powers of mass, powers of length, powers of dimension, t, because the homogeneity, whatever the dimensions raised to the power of mass should be the same dimensions raised to the power of mass this side. Yeah. So this one way you can do it. So f, okay, FAT power 2. I think 2 is the right answer. Okay. Yeah. One more way you can do is mathematically, but qualitatively. Okay, how we can do? For example, same. I want to take the energies dimension m L square t power minus 2. Okay, this should equal somehow force m L t power minus 2. Okay, and then acceleration L t power minus 2 and time t. Okay, I have to look at these three individuals. To see three individuals, I have to look out, and what are the things I have to cancel out? First, I want positive power of mass, so the force should stay in the numerator. Okay, I want L square, so this force has to multiply with acceleration, then only I will get L square. I want t power minus 2. Okay, so remaining t I cannot just put anywhere, I have to put it down or up. Okay, now I conclude that the force and acceleration should be in the numerator because I want ml square, but I don't want the t power minus 4. Okay, I want only t power minus 2. Already we have t power minus 2, t power minus 2. So if you multiply, if you put both in the numerator, you will get ml square t power minus 4. Now what I have to do? I have to divide this by t power minus 2. Okay, then only I will get t power minus 2, the dimension of this. So I have to divide by t square. Okay, so then you will have sorry, I have to multiply it by t square. That's what it means, divide by t power minus 2. So m square t power minus 2 you will get. In the numerator and denominator you will fix. This is also one way. In other question it's very easy to understand. Yeah, maybe I find difficult to explain this question. Okay, let's move to next question. So this is also one of way that you can ask question in dimensional analysis. Two or three dimensions are given. They ask you the combination of these dimensions. E and G denote energy and gravitational constant. Then what is E by G? Very simple. We know that dimension of E is m L square t power minus 2. Dimension of G is m inverse L cube t power minus see, I forgot what is dimension of G. Yeah, t power minus 2. What they're asking, if you divide E by G, so m and m in inverse you will get m power minus 2, L square and L cube you will get L inverse t power minus 2 t. So you will get m power minus 2, no, m power 2, not minus 2, m square L inverse, you will not have t, so t power 0, m square L inverse t power 0. I think one is right answer. Yeah. Okay, let's move to next question. A physical quantity of the dimension. So this is this you can see that the difference in time by solving numerically, sorry, mathematically, just by numbers and equations, and quantitatively you can see the time difference. Okay, A physical quantity of the dimensions of length that can be formed out of c velocity of light, g gravitational constant, and e square by 4 pi epsilon naught. And remember that this looks like a scary question, but of course it's a long question, but it's not a scary question. It's very easy to understand once you know where these things comes from. Okay, then dimension of length you have to find only the length this side. So I have to take length. Okay, so first let's solve numerically. Some power of x, some power of g y, and some power of e square by 4 pi epsilon naught z. Okay, you know that c is velocity of light, so L t power minus 1 by x, and g is gravitational constant, so m inverse L cube t power minus 2. Okay. See, you should not make any dimensional mistakes in the beginning. It will cost you time. And what is the dimension of this quantity? E square by 4 pi epsilon naught. Okay, where we can see this Coulomb's force formula. Force is 1 by 4 pi epsilon naught q1 q2. Okay, let's put that for electron. So e1 and e2, so e square divided by r square. So I want only e square by 4 pi epsilon naught this place. So this r square I'm moving, so f into r square. I know that force is m l per l t power minus 2 into r square, which is m l cube l square. So this quantity formula will be m l cube t power minus 2. Okay, m l cube t power minus 2 for y and for z. Then all you have to do is compare the numerator equations for all the, okay, this side m power 0, l power 1, t power 0, because all we want this side is only the dimension of length. Yeah, okay, so let's equate the m powers here. Here is 0, so 0 equal to this side doesn't have m, so 0x, here minus 1 y, okay, plus 2z. So 0 is minus 1y plus 2z, one equation that we are getting. Is it so? No, not 2z, only m power 1 only, 1 is z plus z. Okay, minus y plus z. So you can conclude that y equal to z. So this is equating the powers of 0. Then powers of L. Okay, so we have L power 1 here, L power 1 x. Okay, L cube plus 3y plus 3z. Something is fishy. Yes. Okay, so x plus 3y plus 3z is 1. Okay, let's keep this equation and then let's equate t. So this side t power 0 is equal to minus 1x and minus 2y minus 2z. Okay, so you will have 0 equal to x plus 2y plus 2z. So we have three equations, three unknowns. We can find DC. So let's substitute. Let's take this equation and subtract. 0 equal to minus x minus 2y minus 2z. Okay, if I just add, this will cancel. So y 3z minus 2z is plus z equal to 1. I know that y equal to z, so I can replace 1 equal to z plus z. So 2z. If 1 equal to 2z, then z equal to simply 1 by 2. If z equal to 1 by 2, then y also 1 by 2. Okay. If z and y are 1 by 2, I can put in this equation, any one of this equation, to find what is x. let's say that I want to put this in this equation. So 0 equal to x plus 2 into 1 by 2 plus 2 into 1 by 2. Okay. So what you will get? 0 equal to x plus 2. So x equal to minus 2. So you found x equal to minus 2, y equal to 1 by 2, and z equal to 1 by 2. So I'll just erase this. Okay. So y equal to 1 by 2, z equal to 1 by 2, and x equal to minus 2. So if you put this, dimension of L will be c power minus 2, okay, g power 1 by 2, and e square by 4 pi epsilon naught power 1 by 2. So this g also you can move into this, and 1 by c power minus 2 meaning 1 by c square into g into e square by 4 pi epsilon naught 1 by 2. I think first one is the right answer. This is one way you can do it. See how long, and uh, the possibility of doing a mistake here is so huge. One more way you can do it, as usual, taking a qualitative. So we need this side dimension of length. Only length should take it. Okay. So this side we have 3 dimension. C is LT power minus 1, and G is M inverse L T power L cube T power minus 2, and E square by 4 pi epsilon naught. So which has a dimension of M L cube T power minus 2. Okay. So now I want only L. So this M inverse and M should cancel each other. So they are M inverse and M. If you multiply them, you will get cancel the mass. So I know that this both have to be in the numerator. So M inverse L cube T power minus 2. So this is G into M L cube T power minus 2. So I have to multiply both so that the M is cancelled. So what I will get? L power 6 T power minus 4. Now C is L T inverse. So what I have to do? I have to have only the L remaining here. Okay. So if I actually, I can square this, cube this, whatever I want to do. Okay. Let's say that I want to square this. So to get this value, I have to do power 6, C power 6. Okay. But if I take the square root of this, then I will get L power 3 T power minus 2. Okay. Half. Now if I divide this with C square, which is L square, T power minus 2. So I will get only the L. So what I am doing, I am multiplying G and E square by 4 pi epsilon naught. Okay, to get the M cancel, I'll get only L power 6 and T power minus 2. And then I'll take the square root of them and I'll divide them with 1 by C square. So I will get the length. So this is how you have to practice qualitatively. So if you're a pro doing dimensional analysis, I recommend doing only this method. This will save a lot of time. If you're a beginner, I suggest you do this for backup verify proof check. Okay, so it will be very helpful. Also, you can by practicing, you can inherit this skill very easy. Initially, it will look like mad, but as you practice more and more, you will get more and more clarity on this method. Yeah. Okay. Let's solve next question. If energy V, energy E, velocity V, and time T are chosen fundamental quantity, the dimensional formula for surface tension will be. So now I think we have crossed the type of question that they can ask. So hereafter only questions will be repeated, but different quantities. That's all, quantities and dimensions. So in this case, first, what's the dimension of surface tension? Okay, the symbol for surface tension is, I think, same tau. I. So this is surface tension. Surface tension is force by length. We know that force is m l t power minus 2 divided by L is m t power minus 2. So this is surface tension. Surface tension is m t power minus 2. Okay. So this side m t power minus 2 should have the dimension, the combination of energy, velocity, and time. Okay. So we know that energy is m L power 2 t power minus 2, some power of this. Velocity is L t power minus 1, some power of y, some power y times t. Okay, let's try the qualitative third. So I want to have mass, but I don't want to have length. So only these two quantities have length. So I have to put in the numerator and denominator. So m L square t power minus 2 divided by L t power minus 1. Okay. But I have L square, so I have to square this quantity. Then both L square and t power minus 2 will get cancelled. Okay. And I have t, but I want t inverse. So 1 by t square. So this power 1 and this power minus 2 and this power also minus 2. So energy power 1, velocity power minus 2, t power minus 2. That's my answer. I think third one is, so, yeah. Okay. So if you want to do it numerically, mathematically, not numerically, algebraically. Okay. Sorry. So m t power minus surface tension is m t power minus 2. This side should have the energy, some dimension of energy, m L square t power minus 2 power x, L t power minus 1 power y, and t power z. Okay. All the m powers will collect. So m power 1 should equal to, so here 1, so 1 into x, 1x plus 0 plus 0. Okay. So x is 1. And L power 0. So this side we have 0. This side 2x plus y. Okay. 2x plus y is 0. We know that x is 1. So 2 plus y equals 0. Y is minus 2. I found out. And z is minus. Okay. T minus 2 this side is equal to minus 2x minus y plus z. Okay. We know that x is 1, y equal to 2. If we put minus 2 equal to minus 2 into 1 minus 2 plus z. So minus 2 equal to minus 2 plus 2 plus z. So z is minus 2. Z is minus 2. So x is 1, y is minus 2, z is minus 2. So energy power x, velocity power y, time power z. Yeah. So this is dimension of surface tension. So energy power 1, velocity power minus 2, time power minus 2. And that's what we found already. Energy power 1, velocity power minus 2, time power minus 2. Same answer. Yeah. Okay. Let's move to the next question. Yeah. If dimensions of critical velocity of a liquid, okay, flowing through a tube are expressed as eta power x. So eta is
Okay, eta. So eta you can either take from a Stokes equation, or so in general this has dimension of force into length divided by velocity into area. Okay, so eta's dimensions are m l power minus 1 t power minus 1. Okay, that's eta. And rho is density. We know that rho is mass divided by volume. So mass divided by L cube. L cube is volume. M L power minus 3. Okay. And the radius of the tube. So R will have the dimension of just length. Now we have to combine these three to get the critical velocity of the liquid. Critical velocity is just velocity. So L t power minus 1. L by t. So one thing we have to notice that only eta and rho has mass, and we do not need mass in the critical velocity, so they have to cancel each other. So one have to go in the numerator, other one have to go in the denominator. So let's put the eta in the numerator, ml t power l inverse t power minus 1 divided by m l power minus 3. Okay, now mass and mass cancel. L power minus 1 we have, so you will have minus 2 here. Okay, you have L power minus 2. What you need is L t power minus 1. So now you have L square t power minus 1. So if this L power minus 2 means L square t power minus 2. And I just have to divide by L. So radius. So if I divide by 1 L, 1 by L, then I will get the answer. Okay. So now it will have minus 1. So t power minus 1 by L power minus 1, which is nothing but L t power minus 1. So eta power 1, density power minus 1, and length power minus 1. Okay. So 1 minus 1 minus 1. That's our right answer. Okay. So you can write this as L t power minus 1 equal to eta power minus 1 rho power eta power 1 rho power minus 1 and radius power 1 minus 1. So x is 1, y is minus 1, and z is minus 1. Okay, you can write like this. Now you can do this question in mathematical form also, but there is a small trick to this question, especially only to this question. Okay, let's try in that method. Okay, we know that eta is m l power minus 1 t power minus 1, and density is m l power minus 3, and r is l. So l t power minus 1, which is critical velocity, must be equal to, so m l power minus 1 t power minus 1 power x l m l power minus 3 power y l power z. Okay, now we have to find three equations and three unknown quantities. So let's compare all the mass. Okay, so mass, this side mass is 0, this side x plus y. So we can get x equal to minus y or y equal to minus x. Okay, let's calculate the power of L. So this side 1 equal to this side minus x minus 3y plus z. Okay, and let's equate t. Side minus 1 is equal to minus 1x. We don't have y plus z. Okay, so you have three equations. X plus y equal to 0, minus x minus 3y plus z equal to 0, minus x plus z equal to 1. Okay, so we can solve this and you will not get a single solution. This equation can have multiple solutions because these are the planes. They intersect in a long straight line. So any point from the plane can be a solution for this. So the clever way to do this, look at the solution and look which number fits in this equation. Okay, x plus y equal to 0. So one half to plus 1, another one half to minus 1. So this has plus 1 and minus 1. This will not. Okay, this will not minus 1 and minus 1. This will not plus 1 and plus 1. So only this is right answer. In just from x plus y equal to 0, you are able to do this. Okay, so this is solving any competitive question is not just about solving. It's about solving and also saving your time. Okay, so for example, I want to solve these equations and then finally find what is x, y, z, and then put it in the compare it with the option. Most of the people, this is a mistake most of the people do. They don't read the options with their questions. You should read the options with your question. Then only you have the idea. You will have the idea what we will get as an answer, so that you can have small idea, uh, small little advantage to work towards it. Yes. Okay. Next question. The dimension of alpha naught epsilon naught power minus 1 by 2. Okay. So power minus 1 by 2 means that we want the dimension of square root of alpha naught epsilon naught. From the equation, we know that this is just velocity of the light. Well, alpha naught is a permeability of free space. Uh, no, yeah, magnetic and electrical permeability and permeability of space, permittivity and permeability. We know that this is equation. So they have the dimension of just C, which is nothing but L t power minus 1. Where we have, yes, 3 is the right answer. Okay. The dimensions of half epsilon naught E square, where epsilon naught is permittivity of free space and E is electric field. So we need the dimensions of epsilon naught that you can get from the equations. Coulomb's equation, okay. So force is Q square by 4 pi epsilon naught into R square. Yeah. So epsilon naught is nothing but F into, sorry, same, Q square divided by F into R square. So Q square, how do you find Q? Q I is Q by T. We know that Q is I into T. Okay, so this goes like I square T square, which is ampere square into T square, divided by force is M L T power minus 2 into distance is L square. So finally you will get M L and L square, so L cube in the numerator, L power minus 3 A square. T power 2 you have, this T power minus 2 if it come, then you will get T power 4. So M L power minus 2 minus 3 A square T power 4, that's your epsilon naught dimension. Okay, and electric field also you can get from the equation, simple equation. Force is electric field into charge. So electric field is force by charge. We know that force is M L T power minus 2 divided by charge is ampere into time. So electric field is M L, this T power 1 goes, then T power minus 3 into A power minus 1. Okay. Now we want epsilon and epsilon, sorry, E square. We can omit this half. Number will not have anything to do with the dimension. Yeah. So epsilon naught into E square. mean that you have to square this entire thing. So epsilon naught is m L power minus 3 a power 2 e power 4 into, I have to square this thing. So m square L square t power minus 6 a power minus 2. Then I will get, sorry, here it is m inverse. M is in the denominator, right? So m inverse. Okay. So m inverse and m square, I'll get only the m. L power minus 3 and L square, I'll get L power minus 3. This will get cancelled. T power 4 and T power minus 2, I'll get T power minus 2, T power 6. So half epsilon naught E square will have the dimension of m L power minus 1 L cube, and so I'll have minus 1 T power minus 2. Okay. Second option is, yes. If the dimension of a physical quantity are given by m power a, L power b, t power c, then the physical quantity will be, okay. All you have to write the dimensions of these quantities and check a, which a power a, b, c is one. Okay, pressure is forced by area. So m L power minus 1, t power minus 2. A is 1, right? B is minus 1, C is minus 2. We are lucky. Okay, we'll check about the other. So this is L t power minus 1. So A power 1, no, M power 0 actually. It's not. Acceleration is L t power minus 2. Again A power, no, M power 0. Force M power 1, L power 1, t power minus 2. So this is also. So pressure is the right answer. Dimensions of resistance in an electrical circuit in terms of dimensions of mass, length, and time t, and current I will. This is a very nice question. So initially, in my school days, I thought, how can resistance have the dimensions of mass, length, and time? But it is very easy to achieve. Okay, we have to use two formulas. One, we know that V equal to I into R. So we want only resistance. So resistance is voltage into voltage divided by current. Okay, this we know fundamental formula. Now we have to find the voltage formula. Okay, so voltage is energy by charge, and we know that charge is current into time. So this is energy by current into time. Energy dimensions are m L square t power minus 2 divided by current is A time t. So this will be, voltage will be m L square t power minus 3 A power minus 1. This is voltage. Okay. So we want current is uh, just ampere. So the resistance will be m L square t power minus 3 A power minus 2. So dimension of resistance m L square t power minus 3 A power minus 2. Yes. Okay. T power minus 3 A power minus 2, where I think fourth option is the right answer. Okay. This you can use from different formula also. Okay. You know that P equal to I square R. From this also you can derive R equal to P divided by I square. Then power is force into velocity. Okay. So it's m L t power minus 2 into L t power minus 1 divided by I square is just ampere square. In this case, we can keep it as I. So square. So m L square t power minus 3 a power minus 2. Same answer you will get. So any formula you can get, eventually you will get the final answer, one final answer. Yes. You see, so the simplest version of formula you can find is the less amount of time you can do the question. Yes. Okay. The velocity v of a particle at the time t is given by v equal to at plus b by t plus c, where a, b, and c are constants. The dimensions of a, b, and c are respectively. So we have to find the dimensions of a, b, and c. So now we have to use the homogeneity. Okay, so we have v equal to a t plus b by t plus c. Have to use our brain. Okay, now t is dimension of c, that is added with c. So c also have to have the dimension of t. So dimension of c is just t. V equal to at. Okay, so this has the dimension of velocity. So at is lt power minus 1. I just want a. A is lt power minus 1 by t, which will be lt power minus 2. So a is lt power minus 2. As simple as that. We have found a, and let's found b. So b, we know that this both has dimension t. So b by t is v. So b will be v into t. So v is L t power minus 1, t is t. So you will get only L. So v is the dimension of length. And yeah, I suppose. So A is L t power minus 2, B is L, C is t. I think 1 is the right answer. Yes. Okay, one nice question using the homogeneity. Okay, let's move to the next question. The ratio of dimensions of Planck constant and the moment of inertia has a dimension of. Okay. We can derive the dimensions from the units also. For example, you know that the Planck constant, okay, H has the unit of some 6.63 is 10 power minus 34 numbers matter. Joule seconds. Okay, joule is a unit of energy. So it's energy into time. Planck constant. Yeah. So energy is ml square t power minus 2 into time t. So ml square t power minus 1. So this is the dimension of Planck constant. Moment of inertia mr square. So ml square. So that's moment of inertia. Okay. So we have to divide Planck constant divided by moment of inertia. So ml square t power minus 1 divided by ml square. So you will get t power minus 1. So frequency, velocity, angular. So t power minus 1 is frequency. That's your answer. Velocity is L t power minus 1, angular momentum, time is t. Okay. So frequency is the right answer. See, very nice question. Good. Oops. I think this question should be put first. Yes, Planck constant has the dimension of. So what's a Planck constant dimension? As we have seen that it's energy into time, which is ml square t power minus 1 Planck constant. Okay. So linear momentum is mass into velocity. Okay. So mass, velocity is ml t power minus 1. Angular momentum has the same dimension as moment of inertia. Okay. Mass into distance square. Or mv into r. So m l t power minus 1 into l. V. So yeah. So m l square t power minus 1. Energy is E m l square t power minus 2. power is force into velocity. So m L t power minus 2 into L t power minus 1. So which is m L square t power minus 3. So the Planck constant dimension is ml square t power minus 1, out of which the angular momentum has the same dimension as Planck constant. So different parameters can have the same dimensions. So we have seen stress and pressure can be the same. So angular momentum and Planck constant has the same. In CBSE book, not in CBSE book, in Arihant book, there is a page that same dimensions, quantities that have same dimensions. Okay, so in future, maybe I'll upload a video on the same dimensions. But as of now, uh, angular momentum has the dimension of Planck constant. Just a minute. Thank you. Yeah. Okay. So a pair of physical quantities having the same dimensional formula. So we have 4 pair which have the same dimension. Just by looking, you can tell work and energy have the same dimension, but we will work it out anyhow. Force and torque. Force is ml t power minus 2. Torque is force into distance. So torque is m L square t power minus 2. Okay, work and energy is same because they are same word. Force into distance. So m L square t power minus 2 and m L square t power minus 2. Okay. Force and impulse. So force is m L t power minus 2. Impulse is force into time. So m L t power minus 1. Okay. Impulse. Linear momentum and angular momentum. Linear momentum is mvr. So m L power 2 t power minus 1. Angular momentum is m energy into time. So m L square t power minus 1. Okay. No, not this one. Yeah, so this is angular momentum. So linear momentum is m into v. So m L t power minus 1. So they are not same. They are not same. They are not same. Only work and energy. Work you can take from power. So power is work from time. L t power energy. Okay, from this power into time also. Any formula you can take, you will get the same. Work and energy. They are same quantities. Yes. For the dimensional formula for magnetic flux is, so magnetic flux is phi, that we know that B into A. Magnetic flux is magnetic field into area. So magnetic field, we can get it from F equal to B I L sine theta. Sine theta we will leave, doesn't have sign dimension. So B equal to F divided by I into L. So M L t power minus 2 divided by A into L. So we will get M t power minus, sorry, M t power minus 2 into A power minus 1. So that's B. Magnetic flux is B into area. So which is area is L square. So M t power minus 2 A power minus 1 into L square. So magnetic field's dimension B M L square t power minus 2 A power minus 1. We have, yes, I think one is right answer. Okay. The force F on a sphere of radius R moving in a medium with velocity V is given by F equal to 6 pi eta RB, the dimensions of eta. So they gave the equation, you just have to rewrite the equation. Okay, F equal to 6 pi eta RV. So leave the 6 pi, they don't have dimension. So eta will be force divided by R into V. So ml t power minus 2, that's force, divided by R is L, velocity is L into t power minus 1. So 1 L will become itself. So m t power minus 1. So m L power minus 1 t power minus 1. I think fourth is the right answer. Yes. Okay. See, this is how you can find the dimension of unknown quantity just using the formula. Rearrange the formula for the quantity that you want to find and then put all the dimensions and work it out on the dimensions. Which of the following will have the dimension of time? This is very interesting question. Okay. So we have self-inductance, capacitance, and resistance. We have to find which has the dimensions of time. Okay. So let's work it out. Self-inductance that we have worked it out already. The dimension is m L square t power minus 2 a power minus 2. Okay. Capacitance has dimension of voltage is energy per charge. Capacitance is charge per energy, I think. Okay. So m minus 1 L power minus 2 t power 4 a power 2. So resistance is V by V equal to IR or equal to V by I. Yes. So resistance we will have m L square t power minus 3 a power minus 2. Okay. So let's work it out the combination. Let's look at L into C. So if you multiply the L into C, you will get m. So m inverse and m will cancel. So you will get. Okay. Let's do the full workout. So m and m inverse cancel. L square and L inverse will cancel. So you will get t square. Okay. And a power 4. So that's not dimension. So L and C will have t square and a power 4. Okay. No, they should not have a power 4. So this is minus 2. Yeah. So just t square, not t. Okay. Let's try R divided by L. R divided by you will have m L square t power minus 3 a power minus 2 divided by L is m L square t power minus 2 a power minus 2. Cancel, cancel, cancel. T power minus 1. So you will have t power minus 1 R by L, which means that L by R you will have t. Okay, quantitative idea. Quantitative. Okay, still we will work out L by okay. M L square t power minus 3 a power minus 2 divided by uh, yeah, R is m L square t power minus 3 a power minus 2. So this is R L is m L square t power minus 2 a power minus 2. Cancel, cancel, cancel. T power minus 1, which is t. So this has dimension of t. C by L, we don't have to consider, but still we will work out C by L, which is m inverse L power minus 2, t power 4, a power 2 divided by L is m L square, t power minus 2, t power minus 2. So you will get m power minus 2, L power minus 4, t power 6, a power 4. So though we don't need for answer why we are doing this as a practice, will help for other questions. Yes. So 3 is the right answer. L by R. Okay. Okay. An equation is given as P plus A by V square equal to B theta by V. So where P is pressure, V is volume, and theta is absolute temperature. If A and B are constants, the dimensions of A will be. Now you have to use the homogeneity. So the A by B square is added with P. So they both should have same dimension. So A by B square should have the dimension of P, pressure. Okay. So A is pressure into V square is, okay, V square. We know that pressure is force by area. So M L power minus 1 T power minus 2 into V square is, V is L cube. So V square is L power 6. So A will have the dimension of M L power 5 T power minus 2. L inverse into L power 6 is L power 5. M L power 5 T power minus 2. Okay. I think first one is the right answer. Okay. See, actually, you do not need to move to this part at all. Just figure out a way to solve the question very quickly, and do not do this in the practice sessions. In practice session, you should elaborate as much as you can for practice. But in main exam, you should find a way which uses the least amount of time. Yes. Which of the following is a dimensional constant? Remember, we discussed earlier what is a dimensional constant. Dimensional constant is some values which has dimensions. Okay, for example, pi has a constant value but doesn't have dimension. So it's not a dimensional constant. So, for example, gravitational constant, permittivity of free space, permeability of free space. These are dimensional constants. So, refractive index is a dimensionless quantity. Poisson ratio is also dimensionless quantity. Relative density, meaning that you have density of something 1 and density of 2. Both have same dimension, so it's a dimensionless quantity. Only gravitational constant, which has m inverse L cube T power minus 2, I guess. Okay. Yes, m inverse L power T power minus 2 is a dimensional constant. Okay, only G is a dimensional constant. Good. Next question. Okay. So you have this equation. From this, you have to find the dimension of eta. Again, we have solved multiple times. If you know the dimensions of eta, you can directly write. Okay. So if you don't know, then we have to work out these formulas. Okay, let's assume that we don't know the dimensions of eta, so we'll work out with this formula. Yeah. So P, the pressure difference. So P is pressure, M L inverse P power minus 2. Okay, this is L square minus L square. So you will have L square. 4 will omit. So V is velocity. So L T power minus 1. And L is length. Okay. So we have L square T power minus 1. So we will have M L power minus 2 T power minus 1. Yes. Both terms are right. If you remember the dimensions, you can directly keep. If you don't remember, you can still work out. Yes. But logically, you have to be sure. Next question. The time dependence of physical quantity P is given by P equal to P naught e power minus AT square. That's not A, alpha. Yeah. Where alpha is a constant and T is a time. The constant alpha. Here you have to use that the trigonometric function, exponential function, logarithmic functions do not have dimension. So P equal to P naught e power minus alpha T square. So this e power minus alpha T square does not have any dimension, or the dimension is 0. Meaning that minus alpha T square's dimension is 0. Okay. So we have T square. So minus alpha should also have the same dimension of t squared. Okay, but they should cancel each other so that the resultant is 0. So this it should have the inverse dimension of this one. So the minus alpha should have, if you put what, then the dimensions will cancel out. So t power minus 2. Then t power minus 2 into t power 2 will get 0. So has a dimension of t power minus 2. Okay. Am I clear? That this entire portion should be dimensionless. This has dimension of t square. So what if you multiply with what, then you get this total dimension as 0. So t power minus 2 if you multiply, then you will get that this dimension as 0. So t power minus 2. Alpha should have t power minus 2 as the dimension of t power minus 2. I hope it's clear. If it's not clear, please let me know in the comment. Okay. So if P represents radiation pressure, C represents speed of light, and S represents radiation energy striking unit area per second. Unit area per second. The non-zero integers x, y, z, such as P power x, S power y, and C power z, is dimensionless. Okay, how we work it out for dimension of length, dimension of time? This we should work it out for dimensions of dimensionless, 0. Okay. So before that, we have to know what is radiation pressure. Okay, so the radiation pressure is ml power minus 1 t power minus 2. Okay, so the radiation energy, okay, so that striking unit area per second, so m t power minus 3, and velocity of light l t power minus 1. Okay, so this is a, if you don't know how we work it out, energy striking unit area. Okay, so energy ml per l square t power minus 2 divided by m l square t power minus 2 divided by unit area, it's l square per unit second, so time, so t power minus 3. Okay, m t power minus 3. So this has the unit of pressure, this has the unit of m t power minus 3, this has the unit of l t power minus 1. So we have to club everything so that the resultant is dimensionless. This two ways we can work it out. One is mathematical, another one is uh, qualitative. So I have m l power minus 1 t power minus 2 and m t power minus 3 and l t power minus 1. Okay, everything should cancel out. So everything should cancel out. So we have, so this, okay, this and this should go opposite. They cannot multiply, they should divide, because both have m, the m will cancel out. And this and this go multiply because we have L inverse and L. Okay, so let's multiply first radiation pressure and C, so that m L inverse t power minus 2 into L t power minus 1. So this will get cancelled. What you are getting is m t power minus 3. Then you just divide it by S. Okay, so m t power minus 3. So overall you get all the dimensionless. So what we have done, p power 1, S we have put in divide. Okay, and C power 1. So p power 1, S power minus 1, C power 1. So x, y, z. Yeah, I think 3 is the right answer. So how you can do mathematically? Um, how you can do mathematically has small, very small twist that we have to address. Otherwise, it will put you in the loop. It will cost you a lot of time. Okay, I'll explain. So we know that radiation pressure has dimension of m l power minus 1 t power minus 2, and this energy per unit time per unit area has m t power minus 3, and set has the dimension C, is the dimension of L t power minus 1. Okay, so m power 0. Okay, so we'll erase everything. Put m power 0, L power 0, t power 0 must be equal to m L power minus 1, t power minus 1. Sorry, m L power minus 1, t power minus 2 power x, and m t power minus 3 power y, L t power minus 1 power z. Yeah, so let's equate the power of m. So this side 0, m power 0 is equal to the side x plus y. That's all. X plus y equal to 0. Okay, so let's equate power of L. 0 equal to minus x plus z. So x plus z equal to 0. Let's equate power of t. 0 equal to minus 2x minus 3y minus z. So now we have three equations, but two of them doesn't contain. Okay, so if you have three equations and three unknown quantities, it is easy to find. When two of the three equations, they are just simply a plane. Okay. Uh, yeah. Okay. So now the idea is, if you try to solve this, for example, let's say that let's put sorry, 3y. Okay. So let's take this equation minus 2x minus 3y minus z. So I want to find x. So for this and this, I put z. Okay. So 0 equal to minus 2x minus 3. X plus y is 0. So x is minus y. Okay. So instead of y, I'm going to put minus x minus. Instead of z, I am just going to put x. Z equal to x. So what you are getting? Minus 2x plus 3x minus x equal to 0. See, it's a loop. Now let's take that equation minus 2x minus 3y minus z equal to 0. Let's find out for y. Okay, remaining everything we'll put in y. So we know that x is minus y, so minus 2 into minus y minus 3y minus, so z is x and x is minus y equal to 0. So minus 2y, sorry, plus 2y minus 3y plus y equal to 0. So plus y and minus. So it will go in a loop. So what's better way to do it? Once you arrive this equation, so instead of going and solving all this problem, just last equation 0 equal to minus 2x minus 3y minus z. Okay, x equal to minus y, z equal to x. Look the answers, found out which satisfy all these three equations. Okay, so z and x should be same, 1 and 1. So here it's same, minus 1 not same, 1 and 1 same, 1 and minus 1 not same. So we have 2. Okay, x is minus y. So x is 1, y is 1. No, not. X is 1, y is minus 1. So 3 is the right answer. So this is how you have to choose. So this is how you can avoid a loop. Eventually, you can find out solution for this equation also, but it's not worth the time doing in the main exam. Yeah. Okay. So the dimensional formula for permeability of free space alpha naught is. Let's assume that we don't know what's alpha naught's dimension. We have to find it. So, but we remember the equation. So the equation is okay, from Boyd-Savart law. You can get dB is alpha naught by 4 pi I T L sine theta divided by r square. So say let's leave sine theta 4 by everything. We just want the alpha naught. So let's rewrite this for alpha naught. dB into r square divided by I into dl. Okay, dB is just magnetic field. So you get m t power minus 2 a power minus 1, and the r square is L square divided by L a. So power 1 a power minus 2. So what you will get m L power 1 a power minus 2 t power minus 2. So I think fourth one is the right answer. No, no, not fourth one. A power minus 2. So first one is the right answer. A power minus 2 t power minus 2. Okay. The frequency of vibration F of a mass m suspended from a spring of spring constant k is given by relation of the type f equal to c power m power x k power y, where c is dimensionless constant. The values are x and values of x and y are. Okay, c is a dimensionless constant. Let's omit c. So the frequency dimension should match, and spring constant's dimension. Okay. So this is T inverse frequency. M is mass, we know. X. K is a spring constant. You know that F equal to Kx. So K is F by X. M L T power minus 2 divided by L. So M T power minus 2. Either you can choose you want to do mathematically or okay. So which combination I will get only the T inverse. Definitely I should divide this and this. Okay. But this should go in the denominator. Then only I will have T power minus 2. Then I should get the square root of it. Okay. So m t power minus 2 divided by m, I'll get t power minus 2. If I take the square root of it, I'll get t power minus 2. Okay. So this I should get the square root of both. So this is y power y power 1 by 2, x power minus 1 by 2. So which option has x power minus, okay, yes, sorry. Actually, okay, this is what I want. So this is just y power 1 by 2 divided by x power 1 by 2. Sorry. Okay. So you will get x is minus 1 by 2, y is 1 by 2. Which option is that? I think 4. Yeah, x is minus 1 by 2, y is 4. Okay. So let's see how to solve this mathematically. So the frequency is m power x and k power y. T power minus 1 is the frequency, is mass over x. Spring constant is kx. So k is f by L. So x is m t power minus 2. Okay. M t power minus 2 y. So let's compare the mass. This side is 0. Okay. Yeah. So this side is 0 equal to x plus y. Okay. So x equal to minus y. X plus y, x equal to minus y. Second, let's compare the length. We don't have to compare time because we don't have not time, length. So time, this side minus 1 equal to minus 2y. So minus 1. So y equal to 1 by 2. So x equal to minus y. So x equal to minus 1 by 2. So this is what we get. X is minus 1 by 2 and y is 1 by 2. Fourth option. Yes. According to Newton, the viscous force acting between liquid layers of area A and velocity gradient is given by F constant is called. Actually, I missed out. So here it should be typed as eta. Eta is constant called. That's a question. Okay. So we have worked it out the eta value many times. So eta is just ml minus 1 t power minus 1. If we don't know, we can find from this formula also. Just rewrite the eta. Eta equal to f dz by a into tv. T is such as length f. So m l power l t power minus 2 into l. This d is l. A is l square. dv is l t power minus 1. Okay, same. L power minus 1 t power minus 1. So m l power minus 1 t power minus 1. I think fourth one is the right answer. So what we have learned from this and some previous question, that the differentiation of x, if x is length, differentiation of x is also length parameter. Okay. The dimensional formula for pressure is nice. So pressure is force by area. So m t power minus 2 divided by t power 2. So m l power minus 1 t power minus 2. 3 is the right answer. Yes. Okay, next. If x equal to at plus bt square, where x is the distance traveled by the body in kilometer, where t is in time, t is the time in second, then the unit of b is homogeneity. So the dimension of x should equal to the dimension of at should equal to the dimension of bt square. What they're asking, unit of p is in what unit? So we have to find the unit of dimension of the p, so that okay. So x is dimension of length. So b t square is L. B is L into t power minus 2. That's all. Or L by t square or L into t power minus 2. So what you should have is length divided by time square. It can be kilometer by second square or centimeter by hour square, anything. But length divided by time square, which has length divided by time square. This is length by time. This is length into time. Okay, this is length divided by time square. This is length into time square. So this length divided by time square. So 3 is the right answer. Nice way of asking. Okay. Of the following quantities, which one has the dimensions different from the remaining three? So we have to work all the dimensions. Energy per unit volume. Unit volume is L cube. So m L square t power minus 3, sorry, t power minus 2 divided by L cube. So m L inverse t power minus 2. Okay, this is one. Second, force per unit area, that's just pressure, which is m L 2 divided by L square, which is m t power minus 2. Nice. Okay, third one, product of voltage and charge per unit volume. Voltage, okay, this is a little complicated. We'll work out the for angular momentum. So we know that angular momentum is mvr. So mass into L t power minus 1 into r is again. So ml square t power minus 1. So all the thing that m L inverse t power minus 2, but this is ml square t power minus 1. So this should be the different one. Okay, angular momentum. But let's work out product of voltage and charge per unit volume. So voltage, we know that this voltage is m L square t power minus 3 a power minus 1 Okay, and voltage divided by voltage, product of voltage and charge. Charge is current into time. So A into T divided by unit volume, which is L cube. So L cube L square. So just have L. A inverse and A in T power minus 2. So what I will have M L inverse T power minus 2. So all these three are same. They are M L inverse T power minus 2. Only the angular momentum is different. So fourth one is the different one from the remaining three. Okay. So if C and R denote, wow, this is the last question. Okay. If C and R denote capacitance and resistance respectively, then the dimensional formula of CR is, okay. We know the capacitance is M minus 1 T power, sorry, L power minus 2 T power 4 A power 2, and resistance is M L square T power minus 3 A power minus 2. Then C into R, this we have to multiply M inverse L power minus 2 T power 4 A power 2 into M L square T power minus 3 A power minus 2. Cancel, cancel, cancel. T. It will have the dimension of just T. M power 0, L power 0, and T. First one. Wow, that's all. That's all the dimensional analysis question as of 2022. 23 question I'll upload as a separate question. Thank you for coming here, Hariharan for Many channel. Welcome to 21st Century Dotting. Thank you. See you in the next video. Okay, small correction. So I made a small mistake in this question. If the dimension of critical velocity. Okay. So minus 1. So we are comparing the dimensions of T. Okay. So it will not contain Z because we have LT power minus 1. Only minus X is here. So this doesn't have T. Okay. So X is 1. We got X is 1. So Y is minus X. So Y is minus 1. So if we have X is 1 and Y is minus 1, you can find the solution of this equation. Okay. Rather than just substituting the answers. So 1 equal to minus 1 minus, sorry, minus 3 into minus 1 plus Z. So 1 equal to 1 plus 3 plus Z. 1 equal to 2 plus Z. Z equal to minus 1. So you can find X equal to 1, Y equal to minus 1, and Z equal to minus 1. 1 is the right answer. Sorry about the mistake earlier. But some question it will keep on looping. So we can substitute the answer options to find. But this have the single solution. Thank you. See you.